All right, guys, by popular demand, I went ahead and took 3 questions from Delta Math, and I tried to look for the hardest ones. So these are the 3 questions that I think are the toughest. And I don't necessarily think that they're hard for you guys. I just think we're just having algebra mistakes and little trig identities and exponential laws and log rules and log properties. So the calculus itself is not hard, guys. It's the algebra. It's the algebra that's hard, guys. So try and see if you can step up your game a little bit to improve your algebra. No, I'm not trying to be savage or throw any shade out. I'm just saying, just invest a little bit of time doing algebra, and I think you'll see great improvements. All right, so let's get into this. So here's one question. It says, what is the particular equation to this with initial condition y equals pi over 2 equals 0? So the first thing you do, guys, is separate your variables. The y's with the y's, the x's with the x's. So I'm going to write dy over, and then the 1 plus 3y's together with parentheses. So they probably want it to stay together. 1 plus 3y equals, and I'm going to write cosine x times dx, so dx. It looks nice and clean. I think we're perfect right here. Hopefully you guys have already had enough experience with this expression, like 1 plus 3y in the bottom here. I'm going to integrate. So because in the bottom this is a linear-like term, I'm going to have ln. I'm going to put an absolute value because there's no limits on your integral there, or integrand. 1 plus 3y. Now, before you continue, if I were to take a derivative here with respect to y, it would be 1 over 1 plus 3y times 3. I don't have a 3 in the numerator, so then that means I got to put a 1/3 in the front of that. Equals, and the antiderivative of cosine, let's see, sine, derivative of sine is cosine, there it is. And then I'm going to write plus c. I don't see any errors at the moment. That's all I see there. I'm going to go ahead and get rid of that 1/3, guys. And the way I'm going to do that, I'm just going to multiply by 3. So times 3 times 3. So I'm going to have now ln, absolute value of 1 plus 3y, equals 3 sine x plus c. Now, in case you're wondering why to not write a 3 in front of the c, 3 times c is still a constant, so I just leave it alone. I guess right now feels like a good time. You could plug in this expression now, but I'm not. I'm going to go ahead and continue. I'm going to get rid of the ln's by doing e and e to the caret. Remember, it's a whole thing there. So e of all that. Now, why did I do it to the e? Because e and ln are inverses of each other. So then I'm going to have absolute value, 1 plus 3y, equals e to the 3 sine x plus c. Now remember, here come your rules. This expression here, guys, is the same thing as e to the 3 sine x times e to the c. And this is just some constant. Some constant. All right, so when I write the c in the front, I'm going to get rid of those absolute values, because I'm going to let my initial condition, this guy right here, determine whether the c is positive or negative. So 1 plus 3y is equal to c e to the 3 sine x. So I'm good right here. I could move the 1 to the right, guys, but now this feels like a good time. I'm going to I should not put a dot because that looks like multiplying. This feels like a good time to use your initial condition. So your initial condition is when x is pi over 2, your y value is 0. So I'm going to plug that in. 1 plus 3 times 0 equals c e to the 3 sine of pi over 2. Now, you need a little bit of pre-calc, guys. It's not even that much. Sine of pi over 2 is 1, and 1 times 3 is 3. So you get 1 equals c e to the 3rd. Now, since I'm trying to get c by itself, I'm going to divide by e to the 3rd. Divide by e to the 3rd. So that gives me that c is equal to 1 over e cubed. Do I got some space down here? All right, I'm going to go ahead and start writing. Well, I guess let's just do one more statement. Where did I leave off? Right there. So I'm going to write 1 plus 3y equals 1 over e cubed times e to the 3 sine x. And then I'm just going to move that 1 to the right. So I'm going to write 3y equals 1 over e cubed e to the 3 sine x minus 1. And yes, I know, guys, I can do something right here. I can just combine it. I'm going to go ahead and move it over here. So I'm going to write 3y equals e to the 3 sine x over e cubed minus 1. So now to get the y by itself, I'm just going to divide by 3. Divide by 3, divide by 3, divide by 3. So now I get y equals e to the 3 sine x over 3e cubed minus 1/3. If you are paranoid, you can leave it alone right here, and Delta Math will take it. The AP exam will take it. Anyone should take it. Even the professor should take it. Now, all right, guys, so here's that same question that we just solved. And look, I'm going to type it in, unsimplified, and we'll see if it takes it. And I think it will. So I'm going to do the first solution that we got. So I'm going to say e to the power 3 sine x, and all that was divided by 3e to the 3rd power, 3e caret 3, and then I'm going to go minus 1/3, and let's see if it takes it. So here we go. Notice I could have easily simplified it more, guys, so it's the algebra that's hurting you guys. Watch this be wrong. Oh, that would suck. All right, so here we go. I'm going to submit the answer. Yeah, I want to submit it that way. And there it is, check mark. And notice, look guys, look at all the notes they give you. So all this is correct, and then I didn't plug it in right there. I did it much further along. Look at the answer that I wrote, and look at the answer that they wanted. So as long as you are correct, so make sure you understand these. As long as you're correct, it doesn't matter, guys. Like, you just got to make sure. I think it's algebra that is hurting you guys. So just make sure you do correct algebra. And it's always the same procedure over and over again. All right, so let's continue, guys. I just put the first 2 videos together, guys, and I noticed that I somehow cut the first screen. And while I could edit it to try and put in a little video, I'm not, because it takes a lot of effort. Well, at least on my part, because I'm not a Camtasia professional. So there it is. You could have simplified it to that, as you saw earlier. They didn't have it that way simplified, but you had a 1/3 here and you had a 1/3 there. So you could have just done like that, where all of that is divided by 3. All right, let's go to the next one, guys. So here we go. We got this expression here, and excuse me, and we want to know, what do we want to know? It says find the particular solution to the differential equation, dy dx equals 5 divided by x plus 2, and with the initial condition y of 3 is 1. All right, so let's go ahead and take care of that one. So again, it's the same thing as last time, guys. I went ahead and, I tried to choose the ones that I thought were hard. So this one looks like it's interesting. So I'm going to put the y's with the y's and the x's with the x's. So here's e to the y minus 1. I'm going to put that, leave that together. So you're going to have e to the y minus 1 equals, let's see, 5 over x plus 2. Close it with a square on it. Oh, I forgot the dy here, dy and dx. Do not put the dy in the front of the e to the y minus 1. Put the dy at the end because it signifies like it's the end there. And then we're going to integrate, so integrand symbol. So there we go. So e to the y minus 1 with respect to y, the antiderivative of that is just e to the y minus 1. If we were to take the derivative of y with respect to y is 1. So there it is. Equals. And then this is just an x plus 2 linear combination, but it's to the power 2. So it's going to be negative 5 over x plus 2. And it's always going to look like that, guys. And then I'm going to put a plus c. So there it is. So now it looks like I'm just going to continue here. Let's see. Does this feel like a good location to solve for c? Nah, I'm not going to solve for c yet. So how do I get rid of that e, or how do I bring the y minus 1 to the bottom? Well, you got to do ln, guys. ln and e are inverses of each other. So when I do that ln, remember, it's a whole shebang here. So y minus 1 comes down, and ln of e is 1. So I have y minus 1 equals, and I have ln, the expression, negative 5 over x plus 2 plus c. And then I guess I could bring the 1 to the right, guys, but since I'm trying to solve for c, I'm going to leave it there. And then I know that y of 3 equals 1, so that the 3 is an x and the 1 is a y. So 1 minus 1 is 0. 0 equals ln negative 5 over x plus 2 plus c. Oh, and I don't have an x plus 2 anymore. Let's see, x was what again? 3. 3 plus 2 plus c. All right, 3 plus 2 is 5, so 0 equals, and let me go ahead and ln of negative 1 plus c. Now, the only way this is going to be equal to 0 for if I have an ln function is if the argument inside the ln is 1. So side note, the only way is if you have ln of 1 equals 0. So there it is. You got to know that little property, guys, and hopefully we know it by heart. So the only way that's going to happen, negative 1 plus c equals 1. So plus 1, c has to equal 2. So now that we know that, I can go y minus 1 equals ln parentheses negative 5 over x plus 2 plus 2. And then just move the 1 to the right. So y equals ln negative 5 over x plus 2 plus 2, close it, plus 1. And you can probably enter that, guys, and that will be the answer, and that will be it. So if you're paranoid, you can stop right here. We're not paranoid. We're going to continue. So let's see if we can put in an answer that that Delta Math doesn't have. Delta Math, I believe, has this answer in there, and I know because it's 5:36 a.m., and this is the question that I actually solved really quick. So if you look at the timestamps are off because I was typing out the notes based on the Delta Math because that's what you guys told me that you guys wanted. So here we go. I'm going to go ahead and multiply that 2 by x plus 2 over x plus 2. So I have y equals ln negative 5 over x plus 2 plus 2x plus 2 over x plus 2 and then plus 1 and then so I'm going to have y equals ln negative 5 over x plus 2 plus 2x plus 4 over x plus 2 plus 1. And then when I add these two guys up, ln, so I'm going to have ln, then I'm going to have 2x. Negative 5 plus 4 is negative 1 minus 1 over x plus 2, close it, plus 1. And there it is, guys. So we're going to put this into DM, into Delta Math. Not direct message, and we're gonna see if it takes it, and it will. All right, guys, let's go to that right now. All right, guys, here's the second question we just did, and I'm gonna insert my second solution instead of the very first one. If you're paranoid, just type in the very first one, guys. They're not asking you here to simplify. So here it is. I'm gonna insert my simplified one. ln open parenthesis. Let's see, 2x minus 1 divided by, and I can already see, okay, so I'm going to have to put another parenthesis. Answer parenthesis, 2x minus 1, close, divided by, perfect, x plus 2. And if it bothers you that there's a parenthesis in the top and not in the bottom, then insert a parenthesis in the bottom. It shouldn't matter. It should still take it. And then on the outside, plus 1. So hopefully we're right. Let's see. And yeah, we're right, guys. And let's see, as you can see here, this is the first one that we got the first time around, and you can just enter that answer there and you would have gotten it right. So the key here, guys, in this problem, just like we stated earlier, is to know that ln of 1 equals 0. So that's probably going to be a common mistake, guys. That's probably what's going to be messing you guys up. It's the algebra and then knowing little properties. So yeah, let's do one more. Maybe we'll do another 2 more so you can see they're not that bad. All right, so let's do this one. So let's get started with this one here. It says, what is the particular solution to the differential equation dy dx equals 2y cubed over 2x minus 3 squared with the initial condition y of t equals negative 1? All right, again, we start with separation of your variables, the y's with the y's, the x's with the x's. So we're going to have dy over 2y cubed equals 1 over 2x minus 3, all that's being squared with a dx. You can put the dx in the numerator if you want, but I like to have it right there, guys. And then I'm gonna move the y cubed up. So I'm gonna write it as dy. I'm gonna put the y to the negative 3 over 2 equals 1 over 2x minus 3 squared dx. All right, here we go. I'm gonna do antiderivative. Integral. So I'm going to write, let's see, y to the negative 2. So it's going to be 1 over, and then divided by 2. So negative in the front, 4y squared. So hopefully that made sense to you guys. If it didn't, just do 1/2 y to the negative 3, add 1, divide by 2, and you'll get your 1/4 there. Equals, let's see, 2x minus 3, linear function. I have a 2 there, so it's going to be a negative 1 over 2x minus 3. Now be careful. If we were to take a derivative of this, I would have a 2 in the numerator, and I don't. So that means you got to put a 2 in the bottom there to cancel out what that would have been if you would have done chain. Then plus c. I hope that made sense to you guys. And then from there, what I'm going to go ahead and do, let's see, what feels good. I think what feels good right here, guys, is just to plug in immediately. So I'm going to plug in 2, negative 1. This guy right there, that's in the top left-hand corner. 2, negative 1. I'm just going to plug it in immediately. So if I plug in 2, negative 1, let's see, negative 1 squared is 1, so I will get 1/4 equals, and then 2 times 2 is 4, 4 minus 3 is 1, so I'm going to get a negative half plus c. And then to get c by itself, oh, that's a negative 1/4 there. And then I almost made a huge mistake there. Then to get c by itself, plus 1/2 plus 1/2, so I'm going to get c equals, so let's see, negative 0.25 plus 50. That's going to be a 1/4, right? Is it positive or negative? It looks like it's going to be positive. So 1/4, there we go. So I'm going to come back. I probably should have just gotten rid of that negative in the front to begin with, but I'm going to come back right there. So negative 1 over 4y squared equals a negative 1 over 2, parentheses 2x minus 3, close it, plus 1/4. And I'm going to get rid, I'm going to change these to, I'm going to change the sign. So if they're negative, they're going to turn positive. If they're positive, they're going to turn negative. So 1 over 4y squared equals 1 over 2, parentheses 2x minus 3, minus 1/4. So stay with me, guys. So what I'm going to do next, let's see, what do I want to do next? I think I want to multiply everything by 4. Do I want to do that? Or do I want to do combine like terms? No, I'm going to multiply everything by, no, you know what? Yeah, let's make life hard on ourselves. No, let's multiply everything by 4. Times 4, times 4, times 4. So 1 over y squared equals, 2 goes into 4 twice, so 2 over 2x minus 3 minus 1. And so what I'm going to do is I'm going to do common denominator here, guys. So I'm going to go 1 over y squared equals 2 over 2x minus 3 minus 2x minus 3 over 2x minus 3. And then from there, what I'm going to do, since the denominator is already the same, 1 over y squared equals 2 minus 2x plus 3, because I distributed the negative there, all over 2x minus 3. So 1 over y squared equals 2 plus 3 is 5, so negative 2x plus 5 over 2x minus 3. And then I'm going to, since I have a ratio or a rational, 1 over y squared and that over that, I can go ahead and just flip everything and they'll still be the same because I have an equal sign there. So as long as I keep everything together. So I have y squared equals 2x minus 3 over negative 2x plus 5. And then I decide to take a square root. Now when you take a square root, guys, you got to take the positive and negative into account. So let's do that in a little bit. So remember, when I plugged in the x value of 2, I better get a y value of negative 1. So let's see, if I plug in a 2, well, I have to get a negative 1, so I put a negative there. So I'm going to test it real quick. 2 times 2 is 4, 4 minus 3 is 1, and then 2 times negative 2 is negative 4, plus 5 is 1, and then the square root of 1 is 1, and then I have a negative on the outside. So yeah, there it is, negative 1. It works, guys. So let's go ahead and type this in into Delta Math and see if it works. Hey guys, so here we go. Last question here. So let's see what we got. So here it is. Fresh problem. Negative square root, and then what is we type? 2x minus 3. That's in the numerator. 2x minus 3, all divided by negative 2x plus 5. It looks like everything's good to go. Submit answer. Yes. And there it is, guys. Let's see what they had. Yeah, no. Uh, they went a different direction. I think ours is way easier. But as you can see, correct math is correct math, so it doesn't matter. As long as your math is correct, you'll be fine. All right, guys, give it a thumbs up, I hope. If you liked it, if you enjoyed it, give it a thumbs up. I guess you could give it a thumbs down if you'd like, but I prefer an up. And let me know if you guys run into issues, and I'll see you guys at the Zoom. All right, later, guys. Bye.